Engineers know that understanding the physics of how pendulums behave is an important step towards understanding all kinds of motion. Many other objects move back and forth regularly like pendulums, such as a wake bouncing up and down on a spring, and the back and forth movement of radio waves. In addition to using pendulums in clocks, engineers use them to detect earthquakes, measure how fast a building is flying, help buildings to resist earthquake shaking, and help robots balance. The question asks to explain how does the oscillation time results when the pendulum starts at position A and position B. The time for pendulum A and B to complete one oscillation takes same time because the relationship between a pendulum that swings through a small angle and the time of each swings, which is the period, remains the same, as if it swung through a large angle. A simple pendulum consists of a ball, which is a point of mass, hanging from a string of length, and a face at a pivot point P. When displaced to an initial angle and released, the pendulum will swing back and forth with periodic motion. The period of a pendulum does not depend on the mass of the ball, but only on the length of the string. Two pendula with different masses but the same length will have the same period. Two pendula with different lengths with different periods, the pendulum with the longer string will have the longer period. This simulation shown that mass of a pendulum does not affect the time taken for one oscillation. For the mass 2.5 kg, the time taken for one oscillation takes 20.3 seconds. For mass 3.5 kg, the time taken for one oscillation is 20.3 seconds.
Aim: to study the effect of mass on the time period of a simple pendulum. The setup for this experiment is as shown. Draw two lines on the surface, one parallel to the edge of table, AB, and the other perpendicular to it, MN, such that the two intersect at the point O. Keeping the thread stretched, displace the bob. Also, check the angular displacement of the bob on the protractor, attached at the top of pendulum C with the clamp. Release the bob so that it begins to oscillate about its mean position. Record the time taken for n oscillations in the observation table.
The period of a pendulum can be described mathematically by the equation where P is the period, the time for one pendulum swing in second. L is the length from the fixed point at the top of the pendulum to the center of the mesh bob. G is the gravitational constant, pi equal to 3.14, which is dimensionless constant.